All right. Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, ladies and gentlemen, and welcome to the webinar, Arduino Technology Application for Smart Light System by Faculty of Engineering and built in environment of Massa University. My name is Aladdin Abu Bakr, and an electrical and electronics engineering degree student in Massa University, and I will be serving as your moderator today. Today we will be hearing a presentation from Dr. Surya Parakesh, and he has obtained his degree in Bachelor of Mechanical Engineering from the University of Sunderland, UK. He completed Master in Energy and Sustainable Development at the UK. Dr. Surya Prakash is a lecturer in the Faculty of Engineering and Built Environment of Massa University. He has 6 years of working experience in engineering industry involving biogas plants projects, manufacturing, precision, gug blocks, and much more. Without further ado, I would like to welcome Dr. Surya Prakash, who will be speaking to us about Arduino technology application for smart light system. All right, Dr. Surya Prakash, the floor is
Hi.
yours.
Thank you. Thank you, Mr. Aladdin Abu Bakar. It's my pleasure. Good morning to all. I am Surya Prakash Vijay Surya. I am currently as a lecturer in Faculty of Engineering, Built Environment, and IT. So today, what I'm going to introduce is Arduino technology application. What is Arduino? So before I start, I would like to show you a microcontroller which is an open source microcontroller, and at the same time it is able to apply it in many applications. For example, light system, sensors. We can use it for journal paper writing. We can use it for to conduct industrial projects, mini projects, big scale projects, or small scale projects. So this is Arduino technology, and this is a microcontroller which is called as Arduino UNO. This microcontroller Arduino UNO contains 14 digital pins. You can see at the side of it you have 14 digital pins, and it has analog pins on the left hand side of it, and it has a ground, and it has a power source of 5 volt and 3.3 volt. So this Arduino also has a switch button over here which we can reset it, okay, on and off. And how you connect this to your laptop is through the USB cable. Okay, this is the USB cable. This is how you connect to your laptop. And through this USB cable is where you will get the power source for this Arduino Uno. Arduino Uno is the name of the microcontroller, and if you build a circuit using it, it is a Arduino technology. Arduino technology benefit of Arduino technology is it is a low cost technology. It operates within 5 voltage, and at the same time it is a very easy to be programmed using C++, and it is a lot of many users have already started to use this Arduino technology, and it is very simple to learn as well. And before I proceed further, I'm going to build a circuit using light detecting resistor, or we can also call it as a photoresistor, using Arduino and a breadboard. And before I build the actual circuit, I'm going to build a design of the circuit using another application called Tinkercad. So this Tinkercad comes under Autodesk, and it is also free, and it is a free web based software. So now I'm going to share the Tinkercad now. Before I proceed further, Aladdin, can you see my screen? Tinkercad screen? Mr. Aladdin?
Yes, sir.
Yes, can you see my Tinkercad screen?
Yes, it's appearing. It's clear. Yes.
Yes. Yeah. Yes, thank you.
All
So,
right.
when you open the Tinkercad, thank you. When you open the Tinkercad, we will normally go to circuits, for example. So when you go back, when you open the Tinkercad, this is the first page it will open, and you won't go to 3D design, you won't go to code blocks and lessons. You straightaway go to circuits, and you click create new circuit. So once you create a new circuit, the page will appear like this, and on your right hand side of it, you can have a lot of basic components like resistor, led, push button, and capacitor, and you have a Arduino Uno over here, and you have a microbit is another microcontroller which is very similar to Arduino Uno, and but Arduino Uno is much more powerful than microbit because it has a more digital pins and more analog pins, and you have a vibration motor, and you have a photoresistor, a PIR sensor, and ultrasonic sensor, and you also have LM35, which is the temperature sensor, and you have a lot of basic components more than this. So before we start to do a design of the circuit, I would probably start to click this Arduino, and then I will drag it on my left hand side, and I will start to click the breadboard. This is a solderless breadboard where it is very easy. We can able to build the circuit without doing any soldering, and very easy to do installation. So I'm going to adjust it now. Okay, and over here. Okay, now the next part is I'm going to choose a photoresistor. Another name for it is LDR. Okay, this is the photoresistor. I'm just going to click it and drag it. In this Tinkercad, if we do want additional photoresistor, let's say if I already take like 4 to 5 of photoresistor, I can just click it and delete it. I can just click it and delete it. This is a very powerful tool to do design and also at the same time to run simulation. Okay, now I'm going to place my photoresistor at any points. So I'm going to choose A10 to place my photoresistor over here. At the same time, I'm going to adjust a bit to look a bit nicer, and I can zoom out and zoom in as well. And I can adjust the whole circuit using my mouse. After I select this photoresistor, I'm going to use LED. Once I type LED, a lot of other components related to LED will appear, but I'm going to use this LED, which is the red color, and I'm going to place it over here. And I need another LED, which I'm going to place it at A40. Another good thing about Tinkercad is when you bring your mouse close to the components, it can able to name the part name of the terminal, which is terminal 1 and terminal 2. And when you go near to the LED, it can name the name of the component leg, which is the cathode, and the anode. Anode will be the positive part of it, and cathode will be the negative leg of it. Same goes to the second LED, which is the cathode and the anode. Okay, now what I'm going to do is I'm going to connect the anode positive leg to the digital pin number 2. Okay, I'm going to do a live drawing in front of all of you. Okay, and I'm going to make it a bit nicer. So if I double click, I can able to adjust it. And if you see, it will align by itself like AutoCAD, because Tinkercad is basically comes under this company Autodesk. So its functionalities is a bit similar to AutoCAD. Most of our mechanical engineers use AutoCAD for 2D and 3D drawing. Okay, so coming back to our circuit, I have connected the anode to digital pin number 2. Okay, and I'm to complete the circuit, I need a resistor. I need a resistor. So I'm going to type a resistor, and this is the resistor. So I'm going to place my resistor at here. And another good thing is I can change the direction of the resistor. For example, I can change it like this. Can you see the resistor is moving? Doesn't matter how I change the direction. I want it to be in this direction where the terminal 1 is on the top, terminal 2 is on the bottom. And I'm going to connect the wire to here. And if you see in the breadboard, the current on the middle part of this breadboard, this is the middle part, and this is the top part of it, and this is the bottom part of it. If you see the middle part of the breadboard, the current travels from top to the bottom. And if you see on the bottom part of it, the current travels left to right. So if I connect my wire here, I can connect this point to the ground. Uh, the reason I'm doing this is because we have three different components, and our circuit is going to be slightly complicated. So in Arduino Uno, we have only three ground. If you go to that ground, it shows G and D. So that is ground, and this is the 5 volt, and the D11, D12, D means digital pins, and if you go to the A, that is all analog pins. Coming back to the circuit, our first circuit is completed for the LED. If let's say we want to choose, we don't want the red color, we can go for blue color. Okay, we can double click it. You can name the circuit LED as an LED1, or you can name it as differently, but I'm going to just keep it what is there is written, which is LED1. And you can change the color of the LEDs as I mentioned before. So I previously it was red color, I changed it into blue. Okay, now I'm going to do the same thing for the LED number 2, but now what I'm going to use is I'm going to use a different digital pin, which is digital pin number 3. Okay, I'm going to adjust it slightly nicely. Make it nicer. So as I mentioned, if you drag the wire, it is aligned from top to the bottom. But if you need to align it left to right vertically, you will see like a plus sign. If I bring the wire at the bottom, you can't see the plus sign and it is not aligned. But if you align, you will see a line straight, and then another line will appear and it's like a plus sign, and then you just release the wire so that it looks a bit nicer. And same goes to that. You need another resistor. You can drag the resistor like this. At the same time, you can click this Control C, which is copy, click it outside, Control V, paste. You will have another resistor. You can use any options to bring your components to the page. So now I have a one resistor. I'm going to place it nicely. This resistor must be aligned straight to the cathode. This is cathode. Okay, basically the current will be traveling from digital pin 2. It's moving into the anode and it will come out of the cathode, and then it will travel to resistor, passing through the resistor, and it will go back to the ground. Okay, so same goes to the second LED. The current is traveling from the digital pin number 3, going into the anode, which is the positive leg of the LED, coming out from the cathode, traveling to the resistor. From here, I'm connecting to the ground. If you see if I bring my cursor to this part of the breadboard, you can able to see that horizontal part of it, sorry, the vertical part of it is connected. So this is connected, and the bottom portion is connected separately, and the top portion is connected. So this is the circuit. Okay, let me adjust slightly nicely. Okay, now we already completed LED 1 and LED 2. Okay, sorry, let me undo back. Okay, LED 2. Now we already completed and it's already connected to the ground. Now I'm going to complete the circuit for photoresistor. The first terminal of the photoresistor, I'm going to connect to ground. So I'm just going to connect it straightly like that. The second terminal of the photoresistor must always connect to resistor. So I have one resistor here. I'm going to control C, I'm going to copy it, and then I'm going to paste. And if when I paste it, control V, which is paste, another resistor will appear, and I can just move the component, and when I want to place it at this part of it, I can place it. I can't place the component like that because in the middle part of the breadboard there is a separator. There is no any electricity flow in the separator. So basically what I'm trying to do is I'm trying to connect the holes on the top part before the separator and the bottom part after the separator. So it must be really connected. But since I need to separate this terminal 2 into 2 points, one, it must connect it to analog pin because sensor always receive input. So analog pin is the one that receives input in the microcontroller. So I need to connect that. And the second part is I need to connect to the voltage to get the power source for the photoresistor. Okay, so now I'm going to change the direction of the resistor, and I'm slowly going to oops. Okay, if I do something like this, I just undo. So if you undo, it will come back to the original position. I'm going to place my resistor terminal 2 with the terminal 2 aligned with the terminal 2 of the photoresistor, which means the photoresistor terminal 2 is same with the resistor terminal 2, and same with that I'm going to fix it to analog pin 0. Sometimes they call it as AO, but the actual name is analog pin 0, A0. And I'm going to adjust it nicely to make it look a bit presentable and systematic. And for the terminal 1 of the resistor, we definitely need a power source. So I'm going to connect it to the 5 volt. This one is as well. I can't leave the wire just like that because it doesn't looks nice. So I'm going to drag it at the bottom, make it nicer. As I say, this is a very powerful tool to do uh, electrical design. Okay, so now the whole system is completed. Okay, now what we are going to do is we need to do a coding for this so that we can run the simulation. So we have for one photoresistor, or another name for the photoresistor is LDR, light detecting resistor, and we have two LEDs. Why we are doing this design is because when the brightness is very high, the LED will shut down automatically. When the brightness is very low, which means the darkness, okay, the darkness is high. When the brightness is very low, two LED will light up. Basically, this is a very automated system and very much aligned to industry 4.0. Arduino is very powerful. Why? Because it is also can be used with the industrial bulb where we use it at home. We can also use actual LED or fluorescent lights, but we must use a relay for it. And it works, it definitely works. I have tried before. So let's start doing the code. When you click the code, something like this will appear. There's many options for it, where it's a blocks plus text and text. So I'm going to use text, and then I'm going to click continue. A standard template of C++ code will appear. So now I'm going to do start typing. I'm not going to start typing on the double slash because a double slash basically it won't affect the code. It is used for the notes. So I'm just going to type my name, which is Surya Prakash Vijay Surya's LED and LDR code automation code. Okay, now I'm going to start typing here. So first we need to declare what are the components we have. So first declaration is I'm going to use LED underscore 1 equals to, it is connected to LED 1 is connected to digital pin number 2 actually. So and then semicolon. Okay, before I write like this, I need to declare the component. So I put integer in front of it and then enter integer LED underscore 2. This is the second LED which is connected to digital pin number 3. So if it's a digital pin number 3, we put it as 3 and then semicolon. So two components has already been declared on the top. The third component will be the photoresistor, which is the LDR. So I'm going to declare int LDR is equals to A0 semicolon. Already declared it. Now what I'm going to do is I'm going to use the void setup. Okay, now the void setup, the previous our actual original template shows that the pin mode LED built-in output. This is to test the built-in LED. If we want to use this code, we must connect it to digital pin 13. A single LED connected to digital pin 13, and we can run it. But now we are not going to do that. We are going to modify this. Basically, we are going to use LED 1 output. And same code, we're going to use pin mode LED underscore 2 output semicolon. And LEDs are output. Okay, I have made a mistake, which is I need to use capital letter for the output, and the input I must use capital letter. LEDs are output. When comes to sensors, which is a photoresistor, is a sensor. Another name of it, as I mentioned previously, it's a LDR. It's a sensor. So LDR is input. So same code, pin mode, mhm, pin mode, LDR. We didn't declare whether it's LDR 1 or LDR 2. So we don't have an underscore, we don't have a numbers. So we put comma and input and semicolon. So this, the first code is already, the three components already been mentioned in the pin mode, and I have made another mistake, which is the P. The P must be in small letter. So PM is only one capital, LED one. This portion and this portion must be the same. So I can't use capital on the top and I use small letter at the bottom. Must be same, exactly the same. So, but if you want to detect the LDR, you must use another function called the serial begin. So serial dot begin, and it comes with 9600 volts. Okay, this is the function for it. So the serial begin 9600 volts. And I just make it a bit nicer. I just put some space. Okay, let's go to the white loop part of it. So before I type on the void loop, I must able to receive the input from the LDR, and I'm going to put another function to read from the serial begin, which is the integer value equals to analog read, because it's connected to analog pin. So analog read, it is connected to LDR, and then I'm going to use a semicolon. Second part of it is I'm going to use the serial begin again. So serial begin again, which is the serial dot print line, and then I'm going to use value is a bit space, and then now I'm going to use the if else statement. So first of all, what I'm going to do is I'm going to basically um, going to use a value which is just going to choose a higher value, which is higher than 900 most probably. Okay, if you want to know this value, once you already done the whole coding and you already run the simulation, extract it to Arduino IDE. IDE stands for Integrated Development Environment. You extract it, and then you, from there, you open the serial monitor and you can able to read what are the values, and then from there you can do some adjustments. So for the start, I will just use above 900, and then if, when you use if, you don't need to use a semicolon. So now the open bracket, okay, and then this is the template. It shows digital right, which is correct, but we are not using LED built-in. We are using LED 1 and high. If you can able to see, there is a delay of 1000 means milliseconds. So 1 seconds equals to 1000 milliseconds, which means the first LED is high and it waits for 1 second, and I don't want it to off. I want the second LED to light up when the darkness is high. This is basically the darkness value, which is the low brightness. So when it is very high, I want two LEDs to light up. So we don't want, when there is brightness, we don't want the LED to light up. We want the LED to light up during there is darkness, when it is dark. Okay, so it's not low. I'm going to make it as high. So LED high. Okay, Same goes to here, and I'm just going to make it a bit nicer. Okay, so this is the one, and we already have it. Okay, the same thing, I'm just going to copy paste. I'm going to paste it over here. But once I paste it, this is for the open bracket is for the if statement. We need else statement as well. So else, if you can see, the color is changed. If you have a wrong spelling, the color won't change. So that is a very good thing, indication, color indication function in this Tinkercad. Is very good, where we can able to identify our mistakes. Excuse me. So now coming back to the else, if the brightness is high, which means the value is low, we want the both LEDs to off. So the LED one is off, which is low. In coding, if you so LED 2, you're going to off, right? It is. Okay, I'm just going to ignore this original template remains, which means when you use a double slash, you can able to write notes. Okay, you can able to write any notes which is important, and it won't have any effect on it. Okay, so I'm just going to delete this. Okay. The else is fine, and we need another bracket to close all the. Okay, think that's all. We already done everything. So now what I'm going to do is I'm going to start simulation. So before I start, I already declare LED 1 to digital pin 2, LED 2 into digital pin 3, LDR into analog pin 0, and then LED 1 output, LED 2 output, and pin mode LDR input. That's correct. And then I already mentioned serial begin 9600. Void loop, there's no any semicolon, and integer value equals to analog read LDR semicolon serial dot print line. Able to see the values of the brightness, okay, the values of the uh, light in the serial monitor. If the value is higher than 900, okay, digital write is LED 1 is high, delay, and then digital write LED 2 high, delay, and then else the digital write LED 1, and then delay, and then digital write LED 2 low. Okay, so off. Okay, that's good. Okay, I'm going to start running the simulation. Okay, it has an issue. Okay, initializer before int. Analog read. It mentions says that there's an error. So expect uncalled. Okay. Okay. Integer values analog LDR serial. As I mentioned, it's the word print, which is supposed to be print line value. Okay, now I start simulation. Okay, the errors I've mentioned. Okay, values and analog read LDR serial print line value. It says error expected initializer before int. Okay, it's correct. Pin mode serial begin and it. Okay, it's void loop. After the void loop, we need and think and then expect unqualified ID before if. Okay, okay, it's there. Print line is there. Is it? Uh, okay. If okay, that is open. LED 1 is high. Okay, LED 2 is high. Digital right. We already declared on top of it. It's good. Let me have a like look at it. Check at it. Okay. Okay. Let's check again. Open, close. Okay. We need another open bracket, which means it's not declaring. Since we're doing a live coding, it is quite hard to make it correct in the first place. Do this. Run a simulation again. LED low in function error. Low was not declared in this scope. Low. If you see low, I have typed it wrongly. It is supposed to be LOW. So I'm going to start running a simulation again. So it's correct now. So this is the good part of the Tinkercad where we need it will identify our error and we have done some modification on it and it is working very well. So now I'm going to show you what is going to happen. So I'm going to click here. If the brightness is high, if you can see, the LED is turned off. The LED is turned off. So when the brightness is low, if you can see, the LED is turned on. Okay, so that is the good part of it. Let's see if I bring it to the middle part of the thing, it's getting brighter. The LED is turned off. Slightly down, LED will turn on. So this is the very good function. We have already designed the circuit and we already start to do the simulation. And if you want to have a schematic view of the circuit, this is the schematic view of the circuit. It will automatically show you the schematic view of it. And it is a very good tool. And if you want to have the circuit view itself, if you click it, it will come back to the original position. And on the right hand side, you can able to test the code. At the same time, if you want to extract it to the Arduino IDE, but before you extract that, you need to download Arduino IDE. You just need to click it on the Google Arduino IDE download, and then an app will pop up. So now I'm going to show you the Arduino IDE. So before I show you, I try to download the code. Once you already download the code, if you see, there's a option will pop up at the bottom. So you just need to double click it. Automatically, it will show the Arduino IDE. Automatically, it will show the Arduino IDE. The code that you build, it's already built in this Arduino IDE. If you want to check the code, you can just verify it and the code is fine and it will mention as a done compiling. Okay, now I have also built the uh, actual circuit for this automated light system. So this is the actual circuit. Okay, and close I'm going to close I'm going to what I say, I'm going to fix it. I'm going to show it to you now. Okay, now I already showed. Okay, this is the circuit and all you can see is it is basically working. If you can see, it is lighting up. If it lights up, it is basically working. And if you can see, there's a built-in LED near to the digital pin 13. So it is working. So once it is light up, okay, I'm going to place my hands on top of the LDR. Okay, sorry, the circuit is out. Let me fix it again. Okay, it's supposed to fix it in the ground. Okay, okay, I'm going to show you again. Okay, I'm going to close the lights and now it is on. Why? If when I place my hands on top of this LDR, basically it is been covered and the darkness is high. When I expose to the brightness, it is off. Can you see? It is off. And I'm closing back again. It is on. Okay, the LDR is on and it is off. So now you see it is off. So that is the powerful main tool of it. And let me try. If I open the serial monitor, okay, because I didn't have a connection to it. So what I'm going to do is I'm going to go to the tools. I'm going to go to there. It is choosing is the Arduino board, and the port will be Arduino UNO. And I'm going to upload it now. Hope it can able to upload. Okay, it's already been uploaded. And when I open, if I go to, there's a file, edit, sketch, and tools. Under the tools, if I go to the serial monitor, I can able to read the value of it, which means the brightness. Okay, that which means the value of the light is something like 826, 839, 832, 834. Okay, now I'm going to stop sharing. Okay, okay, now I'm going to stop sharing. Okay, I'm going to try to off the light surrounding this environment. I'm going to try to check what is the value. Okay, I already off the light surrounding it, and I'm going to share my screen again. Okay, if you see, if you go to the tools, if you go to the serial monitor, it is above 900. When there is darkness, can you see? Just now, the value was the value was like 800 something. Now the value is above 1000. So this is the benefit of it. And we are very much near to the end of this lesson today. And before
All right.
wait first, sorry, so I haven't complete yet. So
All
if you
right.
can see, this is the circuit. So this is the circuit and it is lighting up and my environment is dark and the light is closed. Automatically the LED will light up. And this Arduino technology is very powerful, as I already mentioned previously. And what is the main important part of it is low cost. As you see, I have done a very live coding in front of all of you, which is very tough to do, but if you learn you can able to implement it easily. And another part of it is we can able to apply it for small scale projects, and you can do unique projects like FYP masters, and it's up to you how you're going to make the code very complicated. At the same time you can extract data, you can able to read the value of light. What is the value, what are the environment surrounding that can able to affect the brightness of the light. So that is why we are able to I choose Arduino technology, and you no need to spend a lot of money for it. Again and again, it is a low cost and a very easy technology, I would probably say. And thank you very much for your time. I hope you enjoyed the webinar today. Mr.
All right.
Aladdin,
Thank you,
the
sir.
lesson is
Thanks a lot.
completed.
And sorry for the beginning. We have come to the end part of the
Mhm.
presentation. Thank you very much, Mr. Dr. Surya. Sorry for addressing this interesting topic.
Yep.
And thanks to our audience for active presentation. Hopefully, the presentation was beautiful for everyone. And behalf of MASA, IMECHE, we would like to thank you for joining us today. Thank you for your time and patience. Thanks, everyone.